dear.
Yeah, okay. Okay, very good morning to all. Today's talk, I'm going to talk on non-destructive testing applications in civil engineering structures. As since all the present participants are also dealing with laboratory equipments which may be having the requirement of using these non-destructive testing equipment such that it can help in assessment, condition assessment, and also what would be the present structural strength of the structure. In fact, you can actually assess it using non-destructive testing applications. So at present, the present contents of my presentation today is, first I would go through why should we use non-destructive testing measures. For that, what would be the problems that are going to take place in a structure for which you will have to use non-destructive testing applications. Basically, it is an overview of the problem, that is basically the sources of damage in RCC structures causing distress and instability in the structure. Then, hello, please mute your mics, I kindly request you. Then assessment of damage in a structure and its members. So what is the degree of damage that has taken place in a structure, so that I can do the assessment of that damage using this non-destructive testing applications. The third is repair and retrofit measures. I'm just going to talk very, very briefly onto it. I'm not going to get into it because it's not the particular theme of today's talk, but still I have included repair and retrofit measures to restore back the stability and strength in the distressed RC structures based on the non-destructive testing evaluation. So under the non-destructive testing evaluation, we have ultrasonic pulse velocity testing on concrete members, rebound hammer test on concrete members, carbonation and corrosion test on concrete, as well as rebar locator, that is a profometer which is used. So how do we locate rebar, if it is present or not, what may be the possible diameter, what may be the spacing of the reinforcement which may be present in the already cast concrete member or reinforced concrete member. Then permeability test on concrete to look at its water permeability aspect. Then I'm also going to talk to you about core test, that is core sampling test, that is a semi-destructive test, but still I'm going to talk about it to show you in some cases, if you want to know what is the in situ compressive strength of the concrete, in such a case, we will have to go for a semi-destructive test where we need to extract a portion of the core. Now, basically, I'm also going to show you an experimental demonstration where I have made videos in my laboratory here to show you how the ultrasonic pulse velocity testing is done on concrete members, as well as rebound hammer, as well as the use of profometer, and also a video on use of core cutter also. That is core sampling test is also being included. And the last part is the conclusion. Now, I would like to first talk about overview of the structure. Now, all of us know, all of us in the domain of civil engineering, it is important that we have to know what are the components which are present in a structure. So what are the structural components in a building? Basically, all of us know, but I'm just going to give a very, very brief recap on it. So basically, a reinforced concrete structure will contain columns, beams, slabs, reinforced concrete wall, and definitely the foundation. Usually the load flow takes place from the slab, which is transferred to the beams. The load in turn is transferred from the beams to the columns, and the column load and the load from the column flows all the way back to the foundation, and that load from the foundation is transferred to the soil below. And reinforced concrete walls are also introduced to provide stiffness as well as lateral stability to the building in cases of like earthquakes, shear walls. When we provide shear walls into the building, it would give a higher resistance towards lateral forces. Especially lateral forces are horizontal forces such as earthquakes. Now, as we would see, this is the picture of the Bhuj earthquake which has taken place. This is the basically the picture of the photos of the buildings which have been damaged during the Bhuj earthquake which has taken place in our country. So basically this I have taken from EERI report. That is, from these pictures what you would observe that earthquakes have caused damage to the buildings. So in some, this is a sort of damage where you would see part of the building is damaged. You would see one of the particular part of the building, like the water tank, has collapsed. In some cases, you would see the entire building has one particular floor. All the columns of the particular floor has completely collapsed, or has, buckled or crushed, which has caused the total instability of the building. In some cases, some floors of the buildings have collapsed. We also have damage due to corrosion. That is, when structures are exposed to saline environments, or where it is exposed in the case of, you take the case of a bridge which has been built on a sea, where we have salt water, or we have columns of a small, bridge, which also runs over these drains. If you see it in our Bangalore city itself, we'll have these small bridges which run over these drains. Especially you see this Mysore road. If you go towards Mysore road, you will have that flyover where the columns are actually below the flyover. The columns have been exposed to saline environments, or because of the sanitary and the drain which flows there, which contains basically saline. It has a saline environment there, which causes the concrete to deteriorate and also causes the reinforcement to get corroded. So corrosion also causes damage in the RC structure, where the steel reinforcement undergoes corrosion or rusting, and due to that the concrete cover which is protecting the steel also falls off, due to which we tend to see a lesser load carrying capacity of the structural member. And also because of corrosion, there is a loss of bond between reinforcing steel and concrete. There is a loss of bond, because of which the entire structural members load carrying capacity comes down. So this is a sort of damage. We are also going to see how to measure the amount of corrosion that has taken place in the forthcoming part of the talk. The next is fire damage. When you see today's date, you will read in papers also, and you come across in the news also, that there is a fire breakout in buildings. So what happens when there is a fire breakout? When there is a fire, in the event of a fire, what happens? The temperature of the surrounding goes up, and concrete tends to undergo damage due to high temperature. What happens during the case of high temperature? Concrete undergoes damage in the form of loss of bound and free water in it. So all of us know that we add water to concrete, especially when we are going to mix concrete. The ingredients of concrete are cement, fine aggregate and coarse aggregate, water and admixtures. So water forms an integral part in the hydration process, so such that the concrete tends to harden. So in this case, what happens in the event of a fire? Up to around 250 to 300 degrees centigrade, the bound water in concrete will be lost. The free water in concrete will be lost up to 250 to 300 degrees, and beyond 300 degrees centigrade, there will be a loss of bound water. What is bound water? Bound water is responsible for formation of the bonds in concrete, especially in the formation of ettringite, or which is going to make the concrete bind, the cement in the concrete to undergo hydration, or which has made cement to bind with all the constituents of concrete. This water will be lost. That is the bonds between the hydrogen and oxygen molecules, which are, I would not go into too much of that detail. I would say the bonds which have formed because of this bound water in concrete will be broken. And because of that, there would be separation of the mortar part of concrete. Yes, there would be a separation of the mortar part of the concrete from the coarse aggregate, and also there would be loss of bond between the concrete and reinforcement, due to which there would be a large reduction in the strength of the concrete structural member, means the load carrying capacity of the member comes down. Why am I talking about this? First, we need to understand what are the damages which are taking place in the concrete members, and then comes the assessment. It is like first diagnose the disease and then give the treatment. First, this NDT is basically on diagnosis of the amount of damage that might have taken place in the member. It is like you're diagnosing the structure. Now, damage due to error in design. You would see these are also pictures of the buildings in Bhuj earthquake, which have been designed. In some cases, you would see the columns have not been provided with, this is an error in design. What do you mean error in design? So according to all of us use this IS 456-2000 for reinforced concrete design of members, where there is a certain criteria which have been suggested for design of these concrete members. In this case, if you see, one of the column reinforcement has buckled because of hardly not the spacing of the lateral ties are large. I mean to say the lateral tie spacing has not been provided as per codal provisions and as per design specifications. And if you see also the shear wall here has totally got damaged, which eventually is usually rigid or very stiff. And in this last particular figure, you see where I am just moving my cursor, there is a beam column joint failure, which should not actually happen. If you see this, that is because of erroneous design criteria. So in case of erroneous design also, what happens? The damage will take place in the structure. So in some cases, I think you would have come across in Bangalore itself, you would have read in news, or you would have come across in the news and in the papers, one part of the building has suddenly undergone, it has started to deflect, or it has started to lean over the adjoining building, and it is about to collapse. The BBMP people come and evacuate everyone, and they want to demolish that building. Now, here it depends upon what is the extent of damage that has taken place. See, such cases where the building has totally collapsed, you can't do anything. But when the damage is within limits, one can go for repair criteria. What is repair? Repair is nothing but treatment. Diagnosis is the most important thing. Diagnosis is here, how much amount of damage has taken place is the most important criteria which comes under non-destructive testing. And why we use non-destructive testing is because you can't break the structure and take the structural components and go and test it in the laboratory. You have to keep it as is. It is like a human being going to the laboratory or any diagnostic center. The person has some problem with a stomach problem or lung problem. They take an X-ray or a CT scan to find out what is the problem which has taken place. They do a diagnosis. So we civil engineers also use this non-destructive testing applications to diagnose what is the amount of damage or what is the amount of distress that has taken place in the structure. It also is a part of structural health monitoring too. So now coming to assessment of damage in a structure and its members. Now, what is NDT? Non-destructive testing is used for what? Especially I'm going to talk in the context of concrete structures only today. It can be applied, non-destructive testing is not only applied to concrete, also let me inform you about this. It can be applied to steel structures. It can be also applied to, also in mechanical engineering criteria, you also use it for finding what is the thickness of thin films. You know, in case of thin film coating, which is given to metal members, it is also used to find out what would be the thickness of that thin films which has been coated on metal members, if that film is existing or not. What do you mean by those films? It may be provided for protection purposes for various criteria which comes under mechanical engineering too. At the moment, I would not like to get into that. I would like to talk with respect to constraint to reinforced concrete structures and civil engineering part here. Now, NDT non-destructive testing is used to determine the quality of concrete and what may be the residual stiffness, which also correlates to the residual strength of reinforced concrete structural members after a certain amount of damage that has taken place in the member due to the above said reasons. It may be because of a small earthquake, a small magnitude earthquake that might have taken place. What may be the particular damage that would have taken place in the column members, or what you call in the any of the structural members like columns or in slabs or in beams. But the columns are the most affected, vertical members, especially columns and shear walls, are the most affected in terms of in the case of an earthquake. So, and also this particular assessment of damage, why do I have to assess the damage? First question comes there. Why do I have to use NDT? Why do I have to assess damage? This is used so that when I assess the damage, it is like I'm going to diagnose what is the disease, how much amount of, what is the magnitude of the disease which is present. So what is the magnitude of damage? What is the extent of damage that has taken place? Once I get to know, I will be able to assess if I can repair or retrofit the structural component or not. If the damage is within repairable limits, I mean to say, if you do the assessment from NDT, you will get to know that if the damage is within the repairable limits, I can apply a repair or retrofit. If the damage is beyond the repairable limits, as you saw here in this case, if you see here, this particular beam column joint has failed and a portion of the structure itself has come down here, then it is very, very difficult to go for repair criteria. But coming to when the damage is within repairable limits, you need not have to demolish the entire portion or that portion of the structure, whereas you can use various repair and retrofit schemes which are available to go for the repair option. So first, basically, we have to be very, very clear and precise in our non-destructive testing evaluation. That is a diagnosis. Now, what are the different non-destructive testing techniques which are available? We have ultrasonic pulse test, rebound hammer, acoustic emission testing, which is not there in part of this talk because acoustic emission is not usually used in most of the places because it is also a high-end non-destructive testing technique. I will talk about it very briefly. I'll inform you about it, but I've just included it here in this slide, but it has not been discussed in this part, but I will inform you about it. Acoustic emission testing, core test, which is a semi-destructive. Then we have by visual inspection, you are going to note down few things. When you go to the site, you are going to see what is the type of damage which has taken place. If it is a flexural damage or a shear damage in a particular building, in the form of flexural cracks or shear cracks in a beam, for example. And so in a column also, if there are lesser number of lateral ties provided, means the lateral ties are provided at a larger spacing, you would see horizontal cracks which have come in concrete, reinforced concrete columns. So that also you have to note down. It's part of non-destructive testing, evaluation and monitoring also. If it comes under basically in condition assessment too. Now, the other non-destructive testing evaluations which you have are half cell corrosion, or I'm going to talk about it, carbonation test using phenolphthalein indicator. And also I'm going to talk about concrete permeability test too. Okay, and use of profometer for finding the spacing of the present reinforcement in the reinforced concrete member, as well as it may give us an average diameter of the reinforcement which is present, and it also will give you an idea of what is the concrete cover which is provided, because profometer is also called as cover meter also. But profometer has various applications. It also has, it can be used for finding the reinforcement spacing, average bar diameter which is there, as well as the concrete cover. Now, this is a typical photograph which I put it here in this slide of ultrasonic pulse testing which has been done practically in site. You will see this is used for finding what is the quality of concrete which has gone in casting that reinforced concrete columns, and we have the rebound hammer, the profometer, as well as the core cutting testing which has been done. So I will go into each one of it separately and in depth. So this is one of the buildings which I had gone for assessment. I mean to say, along with, I had gone through what you say, this program of which was provided for going for like an faculty internship. So I had gone to this place where through this internship program, I had gone to, I can't reveal you the details of the project because of technical, secrecy of the client, which we are not supposed to tell. But this is a very old reinforced concrete building which needed assessment because they wanted to check if this building is safe for use or not. Because it's a very old building. What has happened here, I will come to it, that there had been a lot of corrosion damage and also a lot of deflections in some portion of the slabs inside, which had caused the people inside to, and the particular trust of this building, that is the owner and whoever are taking care of this building, they wanted to know if it is safe for use or not, and later if it requires any upgradation, that is repair or not. So in this case, if you see, perform this ultrasonic pulse testing. I will come to it. I will come to it, what it is actually about. I will come to it. Here you would see, this is the ultrasonic pulse testing. This is the rebound hammer, which is used. And I'll tell you here, you will see all these pockets. You will see all this like holes, which has been, you'll be wondering, what is this? The mortar has been removed. I'll come to that when I'll explain it in detail to you. This is the rebound hammer, which has been used. And why is the rebound hammer used? Why is the ultrasonic pulse testing done? I will tell it in detail to you. And this is the corrosion, or this is a half cell corrosion indicator test which has been performed. You can see that here. And this is a profometer, this is the, carbonation test which has been performed. This is the carbonation test which has been performed to know what is the amount of carbonation which has taken place in concrete. I will explain that to you. I'll come back to it. This is the core test. This is the core test of the foundation. This is the foundation, that is an isolated footing which has been cast. A core test is being done where core samples of the particular concrete has been extracted and it has been capped. I'll explain that. It has been capped for testing. Okay, first coming to ultrasonic pulse test, velocity test on concrete. This refers to IS 13311 part 1. It comes under code IS code 13311 part 1. What is the main aim of this experiment? The aim of this experiment is to find out what is the quality of the concrete which is present in the particular structural member. So it assesses, this test gives us an assessment if the concrete is of excellent quality, if it is of good quality, if it is of a fair or a normal quality, I would say it's a fair quality, or if it is of a poor quality. So how do we know if the concrete is being cast properly or not? See, because all of us know that concrete needs to be cast based on a certain, you have a mix design which we follow in our laboratories. I think all of you all are aware of that. When we teach students, we say that we have to follow a certain mixed design of concrete based on IS codal provisions, which are also present, which we all know about it. I don't want to get into mixed design at the moment, but it's with respect to IS 456 2002, where we have a certain guidelines which has also been provided, where we have to follow a certain water cement ratio. Now, all of us know that when we cast concrete in the lab, we follow the mixed design proportions in a very strict manner, because it's in an ideal condition in the laboratory. We follow the water cement ratio, whatever is the quantity of cement, fine aggregate, coarse aggregate, or if it is going to be some amount of admixtures to be used, we follow all that. But inside, at times, apart from ready mix concretes or people from companies like L&T and other than that, people when they are building people who are building houses, you take the example of people who are building houses, they want to concrete the columns, beams or slabs for houses. You would see that, or you would have come across an experience. Actually, when they are mixing the concrete, at times there will be cases where they don't tend to follow the mixed proportions in the right way. We have seen that sometimes they pour more water. That is, the water cement ratio gets affected in that cases. And due to that, there are problems related to what happens when we put more water, the strength of the concrete comes down. Whereas we have to design the concrete member for M30 or M40, when such a condition happens where they pour more water inside, okay, it happens, and mostly it happens. In such cases, what happens? The concrete strength comes down. Whereas the particular column had to be designed for M40, it lands up to become like M32 or M31. When that particular loading for that M40 grade concrete actually gets seated onto the column, whereas the column is supposed to be designed for a mixed design of M40, but it has developed a strength of M32 or M31. What happens? It is going to be under distress when it is going to be loaded. And second case is that you would see a case of honeycombing in concrete. In such cases, what happens? The concrete quality comes down, and so the load carrying capacity of the member also. So let us go into what is ultrasonic pulse testing, how do we do it, and how do we extract the results. See, basically this gives you a quality of the concrete, and I would also like to talk about, see, there is it, we are going to find out what is the dynamic elastic modulus of concrete. What is dynamic elastic modulus of concrete? It is related to the stiffness of the concrete. It is related to the stiffness, and it's a stiffness and a strength parameter. It is a stiffness and a strength parameter. So basically, the apparatus of ultrasonic pulse velocity testing, usually it has a controller. It's a control which is called as Pandit. It's a pulse generator. What do you mean by pulse generator? You see this word ultrasonic pulse velocity. It generates ultrasonic sound. I repeat again, it produces ultrasonic sound. That is, it is through the controller. Okay. And this controller is connected to two transducers or probes. Each probe is actually called as, one of the probes is called as a transmitter and one of the probes is called as a receiver. Actually, let me tell you, both the transmitter and receiver in the case of ultrasonic pulse testing equipment can be interchanged. What do you mean by that? It means to say the transmitter can also act as a receiver and the receiver can also act as a transmitter. And the probes or the transducers which are used for doing for performing ultrasonic test on concrete will have a frequency of 52.6 hertz. Let me inform you that if you are going to have a frequency which is greater than this or less than this, it is going to cause variation in the results, because in the market today you have standard you have companies which sell these equipments, like for example Prosec is there, which is from Germany, and Controls is another company which tend to sell this equipment with these probes. If you go and ask them, I want it for use in concrete, you have to pick up the probes which are having a frequency of 52.6 hertz, because you also get probes for testing steel, the structural steel. So that has a different frequency. If you pick up that, it will not be compatible for this. Next, you have a calibration rod. A calibration rod is usually used to calibrate the equipment before we start the test. I'll come to it. What is the calibration value and all that regarding the equipment, I'll come to that. Then we have electronic timing device. Electronic timing device is not required. If we have today's date, everything is inbuilt into that itself. And vacuum grease gel is required. A vacuum grease gel acts as a couplant between the probe and the concrete surface when it is being applied onto the concrete surface and the probe surface. So basically, from ultrasonic, and let me inform you that how to do the testing, I have made videos which I'm going to play it, okay, to all of you. I'm going to play it for you because since we cannot have a face-to-face interaction because of this corona pandemic, I have made the videos in my laboratory so that you're not left out from the practical sessions. You can get a feel of it. So from this test, what is that which I'm going to get? First, let me explain this to you. Before I go to this particular graph, ultrasonic pulse test, here, if you see this is the concrete member where if I have the receiver and the transmitter probe on the opposite sides of the concrete member, it is called as a direct method. So what happens? An ultrasonic pulse wave, if you can see the cursor, I'm moving the cursor, an ultrasonic pulse wave is generated through the transmitter from the controller. It passes through the concrete and reaches the receiver probe. So what does the receiver probe do? It immediately reports or displays. You see this? I'm just going back to this figure. There is a small display here. It displays the transit time. It is called as the amount of time the ultrasonic pulse wave has taken to travel through a concrete of that particular thickness or length. How much of time it has taken to travel from the transmitter to the receiver. That is what it is going to display. That is which we are concerned about. So when I'm going to I'm going to place my probes on the opposite faces of the concrete column, or the concrete member, not a column only, it can be a beam or slab or whatever, any structural member where both the opposite faces are accessible. It is called as direct probing method. So in one case where I have only two surfaces of the concrete member I can access to, and if I place it in such a case, it is called as, what happens in this case? When I place the probes like this, there is the ultrasonic pulse wave travels in an oblique manner. In this case, the transmitter to the receiver, because I don't have access to the other faces of the structural member. So I have to place it like this. So this is called as semi-direct probing method. Now, I have a case where I have only one surface of the concrete member which is accessible. You take the case of a retaining wall. Okay, you take the case of a retaining wall where I have on the backfill side, I can't go and access on that side. So in that case, what I do in the retaining walls are provided in the basement also. That is basically to hold the backfill earth, that is the backfill soil. So in such cases, what do we do? We place the transmitter and receiver at a certain distance. Please mind you, this is a certain distance. Now, I would like to tell you the distance between the transmitter to the receiver, the distance in the case of direct probing between the transmitter and the receiver is called as the path length, capital L. Please keep that in mind. I'll come to it. It's called as capital L, path length. In this case, in case of semi-direct method, it is the inclined distance. It is the inclined distance between the center of the transmitter to the center of this receiver. That is the path length. In case of indirect method, the third one, it is the distance that is center to center distance between the transmitter and receiver probes is the path length. So what do I do with this path length? So as I told you, the time taken for the ultrasonic pulse to travel from the transmitter to the receiver has been around few microseconds. Okay. That, and I also know what is my path length. The path length divided by the transit time, we call it, or the time of travel, will give me the velocity of the pulse. That's why it is called ultrasonic pulse velocity. That's why the word velocity is used. So pulse velocity by cross probing, or when we use this particular table, you can find it in IS 13311, where you will find, based on the value of the velocity, you are able to assess what is the quality of concrete. If whatever you're going to get, for example, you're going to have the path length in meters, you're going to measure it in terms of meters, okay, and you have the transit time in microseconds. You divide the path length by the transit time, you are going to get the velocity. You have to convert it in kilometer per second units. And if that value is above 4.5 kilometer per second, the concrete quality is excellent. Means it's well compacted and the mixed design, whatever you are expected, it is well compacted and it is of a very good quality. Oh, it's an excellent quality. If the value is between 3.2, 3.5 to 4.5, it is of a good quality. And if it is between 3 to 3.5, it is of a medium quality. It's fair. It's fair quality. Below 3, it is doubtful. What do you mean by doubtful? You can't really depend on such a concrete quality. You have doubts. So I would not call it poor, where the code does not, label it as poor, but it calls it doubtful. So what happens when you get such a kind of a value? In such a case, what happens? You will have to go for further tests. What are the further tests? You may have to go for a core test. That is what it means. It's like you go to the hospital, they do all the tests. I'm sorry, God forbid, no one go to hospital. I mean to say that a person goes to the hospital, they do the test, the doctor finds this should be, anticipates this should be the result, but it comes ambiguous, means it comes very doubtful. The results are very not so clear. The doctor goes for further tests to confirm if this is the problem in the patient. So even in this, when we perform this test, when we get these values, it's nothing like diagnosis. It is nothing but this is part of structural health monitoring. We go for other tests. Now, I would also like to tell you the compressive strength of the concrete here. Here it is a plot of compressive strength of the concrete versus the pulse velocity. What is a pulse velocity? Which we have determined using this. See, we go by direct probing or semi-direct probing or by indirect probing. And let me tell you the first method, it is called as direct probing. Direct probing is the best, I would say, if it is possible. But if you don't have access for the other phases of the structural member, you can't help it. So from this, plot has been made based on a regression analysis, where what we call it as a regression analysis. We have been able to establish a particular relation where you can find the compressive strength Fc from this velocity V. That you can do this in Excel also, in fact. So people who are into this CAD lab, they will have this regression analysis as part of that syllabus. So they will be aware of that. Okay. So the calculations involved. The dynamic Young's modulus of concrete. Here, V is the pulse velocity, which we have just determined. That you converted to meter per second. No, it should be inputted. What is mu? Mu is the Poisson's ratio of concrete. Okay. The Poisson's ratio of concrete, what the particular, even the code says is, it can be taken between 0.2 to 0.2 to 0.3. Even IS 13311 says up to 0.35 you can take it. So I would go for somewhere around 0.27 to start off. What is rho? It is the density of concrete. Plain cement concrete has a density of 2400 kg per meter cube. So from this, it is a basic calculation. If you see this, when I'm just going to plug the values of the Poisson's ratio and the pulse velocity and the density, the pulse velocity is the main criteria in this, which you get it from the measurement. I'm able to find my dynamic Young's modulus of concrete. It is called dynamic Young's modulus because this modulus can change based on what is the value of velocity. And this velocity is one thing which goes on changing. In case if you are going to have cracks, if your concrete is cracked inside, let me tell you, internal cracks are there in concrete, voids are there in concrete, your pulse velocity will, what happens? Increase. The value of the pulse velocity increases. If your value of your pulse velocity increases, mind you, I have put a small expression here. You see, V is equal to L by T. T is your time. If your time increases, what happens? Your velocity value comes down. If your velocity value comes down, your quality of your concrete also comes down. So if the concrete is cracked because of overloading, or it has voids, it has what you call this, it has honeycombing and all. In such cases, your velocity will be low. So in such cases, your dynamic Young's modulus also will fall. Means what happens? The stiffness or the stiffness or as well as the strength of the concrete will come down. So this is the table which is used basically how to take the values down. What we do is that first we have to measure the path length or the distance. It is called as the travel distance of the pulse, the transit time, the pulse velocity, compressive strength, dynamic Young's modulus. See, I would also like to tell you, compressive strength is usually not, actually it's not that clear for concretes which are having strength greater than M30. Okay. So what you need to do in the laboratory or when you go to site, which are the three things which are, can you please mute yourself, sir? I am not able to hear, there is a lot of noise. When we go to site or in the lab, especially to the site, what we do is that first we measure the path length. Okay. Then the transit time is noted down, and from then the velocity is calculated first. Later, when we get back to our office, we can always check with the dynamics Young's modulus and the compressive strength based on regressive curves like this, which we have. We can always get the compressive strength from the velocity. Okay. So this is, and what we do, and let me tell you, when the ultrasonic pulse velocity testing is done, basically what we need to do is, I would like to tell you this, you need to remove the mortar. You need to chip off the mortar from the location where you are going to place the probes. You can see here, the first particular figure which I have shown you, you have to place the probes. See, this is direct probing. This is nothing but the direct method. So you have to remove the, you have to chip off the mortar. If you are going to have the mortar and you are going to perform the test, it is not going to give you the correct results. Let me tell you. If the mortar has separated from the concrete, it is your pulse velocity value will be very, especially pulse velocity value will come down, means your transit time will go up. So that is not the correct method to do it. You have to remove the chip of the concrete. Now, second, each point here, you should take at least 3 to 4 or 5 values each, because the values go on changing. Okay. For each particular point, you have to take at least 3 to 5 values and take the average for each particular location. You can't take only one value and say, okay, I've done it. No, you need to have a mean value of your transit time. Path length is going to be constant. Pulse velocity, you are going to take the mean value. Okay. Let me inform you that. And based on that, also you can find the mean value for your elastic modulus and for your compressive strength. So here I end this part of ultrasonic pulse. The next part comes rebound hammer. What is the use of this rebound hammer? Let me tell you. The use of this rebound hammer is basically to find what is first objective is to find what is the hardness of the concrete. Let me tell you why is the rebound hammer used practically in site. You cast the concrete. All of us know that cement has a setting time, initial and final setting time. So when you use cement in concrete, it tends to set after a certain time, usually after 30 minutes or 40 minutes. It is usually, its ideal is 30 minutes. You put more water, I do not know what may go wrong. Also, it depends on the quality of cement which is used. If the concrete has not completely set, even maybe I've seen cases where inside, maybe after a few hours, the concrete has not set. In such cases, we need to know what is the surface hardness of cement. Surface hardness of concrete, I'm sorry. The surface hardness of concrete needs to be determined. This is like equivalent to your Brinell's hardness and your Vickers hardness, what you have, which you do in strength of materials laboratory. Okay. So basically, what does this hardness value give you? It gives you the amount of strength the particular concrete has developed. That is an indication. It is not a direct indication. It is indirect indication. It is related. Today's date, you get these digital rebound hammers where it gives you the hardness value or the hardness number as well as the compressive strength of concrete which is developed. So this is also one thing, is a mode or a way where you can assess the concrete compressive strength, but I would not completely say that is going to be the compressive strength because you're doing it on the surface of the member. So what do you do here? In this, it actually, if you see all the colleges which had the old type of a hammer, it used to have graduated scale on it, and it will have a spring where it has a plunger where the particular rebound hammer is pressed upon, and once it is pressed and released, it is the rebound action or the reaction force which acts on, that is based on the reaction force developed on the concrete surface, which produces the rebound hammer to push back or give you the particular rebound hammer value actually. So if you see here, basically what we do, we press this until you hear a click sound where the rebound hammer gets locked, and you take the value of the rebound number basically. So the rebound number here will give you an assessment of what would be the possible compressive strength, or if it is basically if the concrete is set or not, or if it is also intact or not. You will get to know about the condition of the concrete at the surface level. I mean to say, I use the word surface level, please. Many people will go with this on the surface. It has become very hard, so no problem, because this is another mode of assessment. So in this case also, you have to take, not at each, you have to form a grid to find the rebound. To use a rebound hammer, you need to form a grid, which I'll show it to you in the video. You need to form a grid and perform the test. Okay, you can't just do it at 1 point or 2 points and say, okay, this is the value. That will not give you the confidence interval for getting you the particular the actual values of the particular. You'll not be able to gauge the concrete quality. Let me tell you in general. So the next part is corrosion meter, or it is also called as half-life corrosion. I know I'm running out of time, so I'll try to keep up with the time. I just request the one second. I just request the organizers, if you can please give me another 10 minutes or 15 minutes time, please, because I have to run the meetings. Please, because that is the most important part where the participants will be able to understand. It's a humble request from my side.
Okay, sir, no problem. Go ahead, sir.
Thank you. So this is nothing but it is called as half cell potentiometer. Okay, and one more thing I wanted to tell all of you. It just flipped out of my head, but I just wanted to tell you. This ultrasonic pulse velocity testing, these transducers will have something called as a piezoelectric crystal inside it. It will have a piezoelectric crystal inside it. So when you're using it in your laboratories or you go to the field, that is the most important aspect through which you are going to get your readings. It depends on that. So if you're going to drop it and all that. One second. If you're going to drop this particular probes, if the piezoelectric crystal which is there inside, if it gets damaged, your probe becomes inactive. It will not be in use at all. Your probe will get damaged. So please be careful. So if you are using it, it is most important that the crystal inside it will be there. So that should not get damaged because of impacts or due to dropping. So this I wanted to tell you. Inform you about this. So, because what happens in most cases, they will not know even in sight it happens. When they go to use the probes, they just drop it from a certain height because of handling issues. And when it falls down, the piezoelectric crystal inside cracks. And they are not aware of it. And suddenly it starts giving you frivolous values, or it may not work at all. Usually it will not work. Now, coming back to half-cell potentiometer, or it is called as corrosion test, or I am combining carbonation and corrosion test together because both go hand in hand. So what is basically in these two tests? Why do I do corrosion test and carbonation test together? Carbonation test is done. It is based on ISO 1920. It is to determine the extent of or the depth of the concrete which has got carbonated. What do you mean by carbonated? There's a lot of. So how does carbonation takes place? You have a lot of carbon dioxide in the atmosphere which creeps into the concrete. Because of that, what happens? there is a lot of carbonation which takes place in concrete. And what is the consequence of carbonation? It will lead to corrosion or rusting of the reinforcement which is present in concrete. So if you see that, basically, if you see that, what happens, you see any of these structures which are present, which are located on these main roads, you would see all the concrete columns and beams, all the reinforced concrete members which are exposed. They are, no doubt they'll be plastered. No doubt they'll be plastered. Plastering will be done. In spite of it, for after quite an amount of time, I can say. This carbonation of the concrete in the structural members will start taking place, and due to that, this rusting or corrosion of concrete will start to take place. And what happens if the reinforcement gets rusted? All of us know. If the reinforcement is gone, the ductility of the structural member comes down. What do you mean by ductility? Or let me put it, the ductility is the amount it can undergo a deformation, the amount of deformation the structural member can undergo is termed as ductility. Okay. Reinforcing, you take steel, copper, as well as gold, silver are ductile materials. Concrete is, I would use a word, quasi-brittle. It's not exactly brittle. Okay, quasi-brittle material, because you have a post-peak part in concrete. Post-peak softening takes place in concrete when you subject it to compression. Means concrete will just not crush like glass or cast iron. All of you would have come across, when you do testing of concrete in the laboratory, you'll put the cube or cylinder, and when you're going to apply the load, it will slowly, the cracks tend to emerge vertically, and after that there is a cup and cone, what do you say, you'll have the failure in such a manner where slowly the concrete deteriorates by cracking. It is not like glass. If you are going to apply compression load on a glass cylinder or a glass cube, it breaks. Or if it is going to be a a cast iron cube or a cast iron small cylinder, it just breaks instantaneously. That doesn't happen with concrete. Even after it attains the peak load, it undergoes slowly, it undergoes cracking and then crushes. So that is called as a quasi-brittle. It's called as a quasi-brittle behavior. So coming back to this, so you have to do the carbonation test and corrosion test together. How do I do the carbonation test? First, you have to use phenolphthalein indicator. You go to any of these chemist stores also, or you go to your chemistry lab in your institution, you go and ask for, or you go to the environmental laboratory also. Any of the environmental laboratory personnel also should be able to give you this phenolphthalein indicator. So what happens? If you take this phenolphthalein indicator, you have to chip off you see this particular figure here, you have to chip off the mortar. You have to chip off the mortar, and where the concrete is there, some portion of the concrete also you have to extract. I will show you that in the forthcoming slide. What you do is that you spray this phenolphthalein indicator. It's a chemical. Okay. So if the concrete, if it becomes pink in color, it means to say that the concrete has got carbonated. Sorry, the other way around. If you have, I will just show you this. It would be here. If the concrete turns pink, this is a case where we have chipped off the mortar as well as some portion of the concrete and we poured phenolphthalein. If the concrete does not turn pink, I repeat again, if the concrete does not turn pink, it means to say it has got carbonated. If the concrete turns pink, you see this figure here, I'm moving my cursor. Actually it's a core which has been extracted. I'll come to that. It is a core through core cutting process which has been extracted. It turns pink. It means to say that amount of concrete has not got carbonated. So if you see here, the concrete around the pink portion here is not pink. It means to say it has got carbonated. It means that much thickness of concrete has got carbonated. So if you are going to have reinforcing rods inside here, they are bound to, at one point of time, they will start undergoing corrosion. Means they'll start rusting after some time. Okay. Sorry. So First is you perform the carbonation test, then you use the corrosion test half cell potentiometer. In the half cell potentiometer, what do you have the components? Basically, you will have what? You will have a positive and a negative, a cathode and an anode. So basically, you will have copper sulfate solution that is filled in actually you'll have two probes. One is you are going to connect one particular polarity on the reinforcing steel, and the other you are going to keep the copper sulfate solution with a pad. It's going to have a pad. You are going to keep it in contact with the concrete. So you are going to create a dipolarity condition. You see it in this figure here. I'm going to show you the figure which we have done also. You'll see this copper sulfate is being kept against the concrete, and the other terminal is connected to the reinforcement. Okay, this is nothing but positive negative. You are connecting the positive negative, cathode to anode. Okay, so from this, what is that which we are going to get out? We are going to measure the voltage. We are going to measure the voltage in the equipment. So what is that voltage? So it is in terms of millivolts, half cell potential millivolts, which we are going to get the value. If the millivolt value is less than -200, it is only 10% corrosion. If it is between -200 to -350, it is 50% corrosion has taken place, which is also uncertain. And if it is above -350, it is 90% corrosion. You see this table you will see here. You categorize the amount of corrosion, means you are going to categorize a corrosion. See, what is -0.42 means it is 420 millivolts. -420 millivolts, it means to say it is above -350. I mean to say from the magnitude point of view. Okay, it's in the negative scale. So I'm taking it like increasing only from that point of view. Here, 90% chances corrosion is occurring in this area. See, in some cases, why do I have to do this particular test? This test is done to see that if that corrosion or rusting is increasing or not. See, you do the corrosion test, you want to see if the corrosion is stationary or it is increasing. Okay, it is like this. For example, is the cancer cells which have been produced in the body, is it stagnant or is it increasing? That is the reason we need to know this. So, and we also know, we need to know what is the magnitude or degree of corrosion which has taken place. So initially, if you are going to have, you see the category 0 millivolts, that is very rare to get that value. You will get a small amount. That is, you get around 70 millivolts. 70, that is 70 divided by 1000. You will get this value. 70 millivolts, -70 millivolts or -140 millivolts, it is put into the category EGF. 90% chance that no corrosion activity is present in that area. You don't have to worry, there is no corrosion which is going to take place. Now, if that value is between -210 to -280 millivolts, corrosion activity over that area is uncertain. Means you can say it may be taking place or may not be taking place. It's somewhere in between. If it is -350 and above, 100%, 90% corrosion is occurring in that area. Chance of the corrosion is going to take place. Here, through the test of carbonation using phenolphthalein indicator, you will get to know what is the depth of concrete that has undergone carbonation. In terms of, you can measure it using a scale that is in millimeters. Okay, the half cell potential is measured in terms of millivolts, and it will give you a percentage of corrosion activity or rusting of the reinforcement in that area. This is nothing but diagnosis of what is happening to your reinforcement or your steel. So it's like this. You see this? This is a core cutting. This is a core cutter sample which has been taken. We have done the carbonation of that for a column. Here you see that there is a certain thickness, maybe around 4 to 5. It's nearly around 6 mm of no, not 6. It's around 3 to 4 mm of the concrete which has got carbonated in that core itself. So just imagine in this column, what is the depth of concrete which has got carbonated? Okay. Now, the next is proformator, rebar locator. This proformator is used, the video is there, I will just show you quickly on that. It is used first is to detect if there is a reinforcement present or not. Is the steel being provided or not? Let me tell you, it happens inside. Certain spacing of steel reinforcement should be provided in slabs or in reinforced concrete walls. Let it be in retaining walls or maybe in shear walls, especially in slabs and these RC walls. Sometimes they tend to increase the spacing of reinforcement because of various problems. That is not problems. Sometimes what happens, if you give it, it may be the error in detailing, or it may be purposely done to save steel. It happens inside because the engineer designs and gives the person at site, the particular contractor, and at times in nexus with the owner, wants to bring down the cost of the building through steel. They'll say we'll provide larger spacing of reinforcement, so lesser steel will be used. They'll say nothing will happen, don't worry about it. In such cases, when there is a distress in the structure, like in slabs, you suddenly start having the slabs start to have deflection and it starts to sag. In that case, what happens, what I've seen practically when I've gone for checking, is you don't know what is the reinforcement which has been provided, what is the spacing. In such cases, we use this proformator to, the probe is placed on the concrete surface and it is scanned. It is moved. It is moved around so that to detect if the reinforcement is there. And first, it gives you a detection reinforcement is present. Second, it will give you the spacing of the reinforcement. Third, it will give you the diameter of the rebar which has been provided, that an approximate diameter. I would not say an exact diameter. Okay. For this also, the plastering should be removed and it should be done. It should not be done with the plastering on. Okay. So basically in this, and also the third or fifth point, you can find the cover thickness which has been provided to an approximate extent. Okay. So you can move this probe in the two directions. You can say in the X direction and Y direction in one particular plane. If you take it in the form of an XY plane, means in one horizontal surface, you will be able to move in one direction. You call it X, and in the perpendicular direction Y. I would call it, means name it in that way. So you will get to know if the reinforcement is present. You can note down what is the diameter of the rebar. These are the observations which you need to take down. As in this case, you have to note down the spacing of the rebar, diameter of the rebar, and in cases the concrete cover thickness. Okay, that is about the rebar locator. This is based on BS 18811 part 204. It is through a British standards, because in India this is the proformator is used extensively. On what basis? It's on BS 18811. Okay. Now coming to permeability test of concrete. Why do I need to do permeability test of concrete? I want to know what is the you tend to have seepage in concrete members, especially water seepage starts to take place, and you'll have dampness, and some case in some liquid retaining structures you tend to have leakage. In that case, what we do is that when we cast the concrete itself, this apparatus is available also in many of the laboratories and some of the institutions. But this is basically done to know what is the amount of permeability of concrete. It gives you an idea of how porous the concrete is, and what is means how much amount of voids is there based on the amount of water which has passed through it, and also the amount of you can say, yeah, it's a void ratio. In this case, what you do, I will tell you, you'll put the you take the case of a concrete cube and place it into the cell. I'm directly coming to it. I'm coming to the apparatus directly. I'm showing you the complete apparatus. You put the particular concrete cube into the cell, permeability cell. Then you are going to have the apparatus where you'll have a water reservoir. A water inlet is going to come through that, and you are going to maintain it at a certain pressure through the pressure gauge. Okay. So you are going to inlet the water at a certain pressure, and you are going to inlet this through the inlet valve here, and this particular water which is going to come on to a certain pressure comes onto the top surface of the particular concrete cube. So what happens, this particular water which is under pressure tends to seep through the concrete member, or which is a cube here, and what happens? It starts to drain out. So you have a drain, but here it tends to drain out. So it gives you the amount of inlet water and the amount of water which is being permeable through the particular concrete member. How do I get to know about that? So here there is a small calculation which is done, the coefficient of through the coefficient of permeability. So this coefficient of permeability depends upon your, here it depends upon your water cement ratio of concrete which you have used. So what is this coefficient of permeability? How it is measured? We will see here. Q is the quantity of water in milliliters percolating over the entire period of test. Now, here you can't perform this test. I'll allow water to go through this particular chamber and it comes onto the specimen, and I'll do it immediately. No, you will have to leave it for a period of 24 hours. Okay. For a period of 24 hours, you're going to maintain the water pressure. You're going to set a certain water pressure. The pressure is maintained and the water is pumped in, so that you will get to know how much it has permeated, how much amount of water is permeated through the particular concrete member. That is the reason for that. See, in any of our houses also, when it rains, only if the concrete slab is cracked, the water will come in immediately. But in certain cases, after raining, after a certain amount of time, you'll start seeing damp patches in your slabs, right? It does not happen immediately. That is through permeability of, or it is basically through the water passing through the voids and micro cracks which have been formed in the concrete. So this it also gives in the case of new concrete also, mind you. If you are going to cast, it's a new building where the slabs have been cast, and they put the water for curing. They allow the water to be ponded on slabs for curing. You'll see water is dripping below. That also gives you an idea. If too much of water is dripping, it also gives you an idea to say that the concrete has a lot of voids also. It has not been compacted well. So, sorry. So quantity of water is in Q is nothing but, you see the coefficient of permeability is measured as Q divided by A into T into H by L. I'll explain that very swiftly to you. What is Q? Quantity of water in milliliters percolating over the entire period of test after the steady state has been reached. What do you mean by steady state? You are going to maintain a certain pressure and you are going to allow that water to percolate steadily over a period of time. Okay, so this is nothing but your chamber. You are going to put your concrete cube here and going to allow that. Now, this is done in the lab to know what is the particular, when they cast concrete, even in the site, they also cast samples of concrete in cubes and cylinders. So that cube and cylinder can also, especially the cube, can be taken and brought into the laboratory to do the this permeability test also. Okay, so basically the dimensions of the cell are basically of the order of 170 and 330 and even 115. You see that you have different cell sizes which are present based on the concrete specimen sizes. But especially for 150 mm cubes, the standard size is 170. You need to have a gap of at least a little of 10 mm and on either sides. Now, coming to Q, K is equal to Q divided by A into T into H by L. Q is the quantity of water in milliliters percolating over an entire period of time of the test, which I told you. Area A is the area of the specimen of the cube. What is the area of the specimen? 150 into 150 mm. If it is 100 and 100 by 100 mm cube, actually 100 by 100 you can use, where you can use a cell size of 115. Okay. If it is usually 150 mm cube, you go for 150 by 150. T is the time in seconds over which Q is measured. So how many hours you have left it? So that hours you convert it into seconds. Okay. H by L is the ratio of pressure head to thickness of specimen. So pressure head, what do you mean by pressure head? In this particular water reservoir, you can measure a pressure head. It will be in terms of you'll measure it in terms of, you can convert it to millimeters, a pressure head which you have. You will measure it. And what is the thickness of the specimen? Thickness of the specimen for a 150 mm cube is definitely 150 mm. So H H by L gives you that ratio. So from this, for different water cement ratios, you can see 0.32, 0.5 and 0.6, the coefficient of permeability is measured. That's 1 into 10 to the power of minus 3, 10 into 10 to the power of minus 3 and 100 into 10 to the power of minus 3. See, if you see here, when the water cement ratio is going on increasing, your coefficient of permeability is also increasing. What does this mean? It means to say that there is more number of voids which are there. See, what happens when you are going to have a strength, a concrete which is having, what happens when your water cement ratio goes up for a particular mix? Your strength comes down. Why does the strength come down? Can you tell me? Because there is more amount of water, you will tell me. What does that more amount of water also result to? A lower amount of strength, which can give rise to, I would not say exactly if it is compacted well, but it also gives rise to, there may be a larger amount, I can say comparatively, I use the word comparatively, number of voids which may be present, because of which water tends to percolate more. Okay, so that is about permeability. That's most important. Now, why should I do this permeability test? If the concrete is very permeable to the water, what happens? There will be reinforcement inside. If it's a very permeable concrete, it can lead to corrosion of the reinforcement because of water percolating into it. That is why if you are going to have your slabs and in your houses, if they are slabs and reinforced concrete members are having dampness, that has to be addressed. Proper waterproofing has to be done onto the surface, or else if you let it like that, over a period of time, the reinforcement will get corroded. Please keep that in mind. Now, next is the semi-direct test. It's a semi-non-destructive test. It's a semi-non-destructive test which is called as core test. In this case, what we do is that we use the profometer first, locate where are the rebars, which I'm going to show you. You have to locate the rebars, and where there is no reinforcement present, I repeat again, where there is no reinforcement present, a core of the concrete is drilled and it has been extracted for in situ, from the in situ concrete, so that this core, which is drilled and taken out, can be tested in laboratory under compression to know what is the in situ concrete strength which has been developed. This core test is done when we tend to have doubtful nature of concrete, which may come out from ultrasonic test. From ultrasonic test results, when we get to know that the value of the velocity is doubtful, in such cases we'll have to extract the concrete, and even your rebound hammer value tends to give you some values which you are not very confident about. You go for core test, but core test should be provided, it should be performed, and the concrete has to be extracted from the zones where there is no reinforcement running. If you are going to bore through a portion, and cut the reinforcement, then you are causing more distress to the structure. You are not supposed to cut the reinforcement. You have to extract the cores where there are no reinforcement present. How do I know that the reinforcement is present or not? You have to perform using, you have to use a profometer, which I just told you here. This profometer should be used to locate where is the reinforcement. And you see this, I'm moving my cursor. You have to locate you have to mark it with a chalk, which I'll show you in the video. You have to mark it with a chalk where the reinforcements run, and the portion where the reinforcements are absent, which you have detected to a large accuracy level. Then you use the core cutter to bore a core here to extract the concrete from that portion. Never ever go and cut a reinforcement. I will tell you, you are going to cause more distress. It's like you go and cut the reinforcement in a column, you had it. You are going to be in trouble because you are going to reduce the strength in that particular portion of the column. Now, so in this, the particular, according to this test is performed based on ASTM C4277 standards, and basically the core is extracted such that, and later it is cut. It is cut in such a way it has a height to diameter ratio of 2, like any of our concrete specimens. If we take our cylinder concrete specimens in our laboratory, you have a height of 300 mm and diameter is 150. So height to diameter ratio is 2. Okay. At the same time, if you are going to have a 200 mm height cylinder, your diameter is 100 mm. So 200 by 100 is diameter is 2. So basically, with respect to this, you will have to you have to chamfer off the portions from the core to create a ideal height to diameter ratio of 2. In some cases, the core gets broken when you remove it. You can't maintain a height to diameter ratio of 2. In that case, you can go for 1.75, 1.5, 1.25, and 1. In that case, what happens? A correction factor needs to be incorporated when you can't maintain a height to diameter ratio of 2 because of various reasons. I will just show you in the video. When you are pulling the concrete sample out, it breaks. You can't have a height to diameter ratio of 2. In such cases, you have to give a correction factor, that is 0.98, 0.96. You see, for a height to diameter ratio of 1.75, 1.5, 1.25, and 1. This is also specified in our IS code 516. Let me tell you that. This is also specified. So the correction factor calculations are such that it is applied to get the corrected concrete compressive strength. That is important. You see, there is no correction factor when you have load to height to diameter ratio, the height of the particular core. That is, it's like a cylinder. It comes out height of the cylinder to the diameter of the core, which is extracted. If it's 2, no correction is required. But if you're going to have a value which is less than 2, then you will have to apply this correction factors. See, I'm moving my particular cursor here according to ASTM C42 is in this particular column, and if you are according to IS 516, you use these particular correction factors for the corresponding height to diameter ratios. See, and mind you, the height to diameter ratio correction factor is 1 for 2, means absolutely you don't have to use that. Now, in this particular case of core, what you need to do, most important when you are going to extract the core, you see this figure, when you're going to extract the core, you need to give an ID to the core. You have to write one ID, location 1, based on the location, from which location, which part of the column you are taking it. Is it on the top portion of it's on the top end of the column? Is it in the middle end of it's in the middle portion of the column, or is it in the bottom end of the column in case of a column? Or if it's in the case of a beam, with respect to its positioning, where is it? It is to the left or to the right in the web. Okay, if it's in the slab, which portion? You have to locate it, or you have the plan. You have to have the plan of the building and then go for it. Okay, and you have to give an ID for each core, 1, 2, 3, or whatever you name it. It is important, or else you put all the cores together, you will not be able to identify which core you have extracted from where. Okay, you should have the location with respect to that ID. You should measure the core diameter. The core diameter goes with respect to the drill bit which you are using. The core drill which we are going to use, it's based on that diameter. You get a diameter of 75 mm, 100 mm, and 150 mm too. And the core length after grinding, means after you have chamfered the edges. Then you have to do core length after capping. Capping has to be done. In some cases, sulfur capping is done such that you get an even surface when you do the compression test. Then you have to measure the weight of that core to know its density. You will know how you measure it using an electronic or a weighing balance is used to measure the weight. Why is the weight used? Why is the weight measured? It's important to know what is the density of concrete that has been developed. It should be 2,400 kg per meter cube. Ideally, it should come around that. If it comes too less, then it is a concrete. If it's a normal concrete and it has the density less, then it is a problem with the mixed proportion which has gone into effect for casting that concrete. Maybe they have put less coarse aggregates or whatever it is. They have not followed the proportion. So this also comes in part of forensic engineering also. Let me tell you, this is how forensic sciences they do. No, they find out what is the reason for this thing to have, for a particular event to have happened. We see that if there is a collapse of a building, of an RCC structure, we also do all these studies. Then your L by D ratio, what is that? Height to diameter ratio is also found. Okay, so then cross-sectional area, then your cross-sectional area is pi d square by 4. What is the diameter? You know the diameter is d, pi d square by 4 is your cross-sectional area. Ultimate compressive load, you put it in a compressive testing machine and you find what is the maximum load it takes. Then you get the core strength, that is ultimate compressive load by cross-sectional area will get the core strength. If in case if your value of your L by that is height to diameter ratio is less than 2, then you apply the correction. You apply the correction factor. You use IS 516 only, no problem, because it's our IS code. You use that and apply the correction factor. Find the corrected strength. This is the measured strength. You see this? I'm using my cursor of here. This is the measured strength in the expression. Phi r is the bar diameter. You don't have to worry. That's why I said the bar diameter need not have to be taken into consideration. Okay, where is the least bar diameter which comes there in and around the core? You have to measure that. What is the core diameter? Phi c is the core diameter, which is here. Phi c is the core diameter. Phi r is the bar diameter near the core. Distance of bar axis from nearer end of the core. You have to, distance of the bar axis means the longitudinal axis of the bar. That is why I came back to this formula. I didn't explain this formula earlier. Now I'm explaining it. L is the core length. This is the core length. So you put this. So what you do, you are going to make a summation of this, how many cores you have taken in that particular area, that you have to take it into consideration. That is this core number 1, 2, 3. I mean to say around that area, not in the same location. Around that location, if you have extracted too many cores, and you should not extract too many also in that same area. But if there is a necessity, how many? If it is only one core, then it will be only one particular value. Then you are going to use the corrected strength, correction factor you are going to apply, and find the corrected core compressive strength. And in case whatever you have observed in the test, the core concrete, whatever it has been extracted, has crumbled suddenly, that you can put it in the remarks. Means the concrete is not stable, that you can put it across in your remarks. So I would not go into retrofitting of structures, but I will say, I'm just saying, why are we doing all this non-destructive testing? All this non-destructive testing is done such that, it is done in such a way that you are going to extract all this information, and what you are going to do with this information with the quality of concrete or the strength of the concrete. If it has reduced, then it is, if the strength of the concrete is supposed to be like M40 and it is turned out to be M30, you will have to go for repair and rehabilitation measures. You can't demolish that concrete column. Instead, it's like a person fractures his hand or leg. You can't cut off the hand or leg. What you do? You go and get a plaster done, right? They put a plaster. That is a repair strategy which is done to repair that particular fracture, right? Similarly, in this case, what we do is that we get to know the diagnosis of the structure through NDT, what is the particular residual strength or stiffness or the condition which is existing, and we go for repair or rehabilitation measures. I will not go into the calculation part of it because I thought this is important. I should tell you, because the whole point, you know about NDT. Why am I doing it? I assess the structure. Then what? After this, having the data of the NDT, we go for repair and rehabilitation. Basically, what is repair or rehabilitation? It is it's a strategy which is used to strengthen a damaged structural component or a structure to bring it back to its original strength. Like M40 concrete has come to M30 due to casting errors. That guy has put more water in the site, so it has come to M30. So what happens? The concrete column which has been cast with such a concrete will have lower load carrying capacity. So there is probability it can develop cracks. So in that case, what do I need to do? I need to go for repair and rehabilitation measures. In that case, where I want to bring it back, I want to bring that particular load carrying capacity of the column equivalent to the concrete of M40, which should have been. In that case, I go for repair measure. Now, in case I have already built a building which has maybe it is a 2-storied building, ground and first floor, and there is a necessity, the plan sanction is there. Based on the plan sanction, the particular place can be, another 2 more floors can be allowed according to the actual norms. In that case, but your columns which have been cast in the ground floor is not up to the strength, or it is not having the load carrying capacity for another 2 floors. Just think, when it has been designed, the owner decided, let me design this building only for ground plus first floor. He had not thought about the future. Maybe he designed the foundation for 4 floors, but when he was building the building, when he was constructing the building, he saw to it that the reinforcement and the concrete, not only the concrete, the size of the concrete columns was made such that it can only take ground and first floor, maybe because of financial constraints. Later, he realizes that he wants to put 2 more floors. The concrete columns are not sufficiently strong enough to take another 2 more floors strength. In that case, you go for retrofit strategy. In that case, where you strengthen the structural member beyond its original strength. In that case, you go for retrofit strategy. Repair and retrofit of structures can only be done when the damage or deformations, means whatever deformations it has undergone, are within repairable limits. Like I showed you in the previous slides, like this, like the Bhuj earthquake. I will not take much time, please. I'll quickly conclude. You see here, you can't do anything about a structure like this which has collapsed. You can't take it and put it and fix it back like using any of these adhesives like Quick Fix or Fevicol. I'm saying on the lighter side, nothing can be done. Maybe I will show you in the next slide, something can be done about this column where the column reinforcement has buckled. Something can be done about this shear wall, which it can be repaired. How? I will just show you and stop after that. Because there are calculations involved for retrofit and repair strategies too, which I am not going to get into it at this juncture because that's not within the scope of this talk. So basically, the materials which are used for repair are, all of you should be also knowing about this. Epoxy to seal cracks, high strength epoxies. And let me tell you one thing. I wanted to tell you regarding this core cutter. When this core cutter is used, this core hole is being formed, right? What do you do with that hole? Many people will have this doubt. He told about, you'll be thinking, I just told you about removing the core and testing. What about that hole which is existing? A high strength grout, a high strength cement based grout is actually, or concrete grout is used to fill that particular core. A high strength grout is used. Okay. So it should not be just left like that. So that, that high strength grout should be having a compressive strength higher than the compressive strength of that particular concrete also. So let me tell you that. I wanted to inform you that. Now, the materials used to repair or retrofit are epoxy to seal cracks, FRP, fiber reinforced polymer sheets. That is carbon, CFRP means carbon fiber reinforced polymers, GFRP means glass fiber reinforced polymers, and AFRP means armored fiber reinforced polymers glued to the concrete surface using high strength epoxy. It is like, you know, how all of you would have come across how you stick these laminates, you know, when you have made all these cupboards, or you see these cubicles, they will stick this laminate over the plywood, right? They will put Fevicol and stick it, Fevicol or Pidilite or whatever. That is an adhesive. That is an adhesive. In this case, we use a high strength epoxy. What does an epoxy contain? It contains an epoxy resin and a hardener. So both are mixed, and FRP sheets, they are in the form of a fabric form. What do you mean fabric form? Like a cloth. Okay. So it will have fibers, or it will have fibers in different orientations. That is taken and it is stuck. I mean to say, it is like, you know, glued onto the surface, and a roller is used to squeeze out extra epoxy. Steel plates are used, and in some cases concrete or cement mortar with epoxy to patchwork, epoxy to bond old and new concrete, epoxy to fix new bars in existing concrete to create a link. Now you want to put new bars onto an existing concrete. What to do? Epoxies are available where you can drill a hole, insert the rod there, and use a high strength epoxy to glue a reinforcing steel rod with concrete. Such things are available today. So you see this particular column which has got damaged. This is the carbon fiber reinforced. What is done? First, a proper concreting is done and it is plastered, and CFRP is wrapped around it like a bandage. This is the case of reinforced concrete jacketing. This column is under distress. What do? We remove the plaster and the concrete cover we remove, and we put a mesh around it, and we retrofit it to increase its load carrying capacity. How did I get to know what is the existing strength? I do the non-destructive testing to know what is the existing strength or what is its existing load carrying capacity. Based on that, what is the extra load carrying capacity that needs to be enhanced or to be increased. For that, I design the retrofit, and I put this reinforced concrete mesh, this reinforced concrete cage outside this mesh, and I concrete it using micro concrete, or it's concrete which is used. Usually self-compacting concrete is used for the retrofit. So here also you would see, this is the damage part where damage assessment using NDT is done and later the retrofitting is applied. You see this? This is a case of a flat slab where the flat slab capacity is less. It is because of low punching shear action, because of the steel plates along with reinforcement is provided with shear keys. You see this? You see this U-shaped shear keys. That is to provide link between this existing old concrete and new concrete. So I would like to conclude and then go to the videos very quickly. NDT is a tool to assess the existing quality. What is NDT? Non-destructive testing and evaluation is a tool. It's a tool, okay, to assess the existing quality and strength of existing structural members. Also, the quality of concrete you get through ultrasonic pulse velocity. UPV is ultrasonic pulse velocity, is determining the quality and the existing strength of concrete members. Existing strength, how will you get? Through dynamic Young's modulus and compressive strength, which I showed you through one of the graphs. Rebound hammer is useful in assessing the compressive strength through the surface hardness of concrete. Okay. Concrete permeability is useful in assessing the porosity in concrete. That is how porous a concrete is. Assessing the, which also gives you an assessment of durability. How long will this concrete be like this? If water keeps seeping through, it can eat up your reinforcement. So you have to, it is a durability aspect. Carbonation and corrosion tests help in assessing the depth of carbonation and degree of corrosion of steel reinforcement, which is existing in a structural component. Profometer helps in assessing the rebar spacing, average diameter of the rebar. I would like to put it on record, average diameter, and the concrete cover thickness. That is also an average basis. Concrete, the core test is a semi-destructive test, which helps in assessing the depth of carbonation and the compressive strength of the in situ concrete which has been cast. When your UPV, ultrasonic pulse velocity, as well as your rebound hammer results start giving you doubtful values, then you go for core test. Okay, so you want to know, or you also want to go for assessment of what is the in situ compressive strength. You do use a profometer, find out the rebar spacing. Where there is no rebar, you perform the core test. Now, I would go through a couple of videos very quickly